Once upon a time, there was a kingdom called Cadmes. Cadmes had plenty of Dassault Systèmes software, which had useful tools for virtual commissioning and digital twins. Nearby was the kingdom of Omron. Omron produced hardware for manufacturing, like PLCs and sensors, among other things. They both saw a problem. Virtual commissioning and digital twin technology was taking the world by storm, but they knew small and medium-sized enterprises, particularly those that build machines, were being left behind. Marcel from Cadmes said, "My biggest frustration is that I'm never able to show a practical example which you can touch, see and smell to my audience during my presentations. I only have a small 7-second video of a PLC with some blinking lights to say, look, this is virtual commissioning." Thanks to these problems and more, these enterprises thought this technology was not useful. It seemed too expensive, would take too much time and training to implement, and looked unachievable, all for little benefit. The whole thing was simply too mystifying to be believed. So Cadmes asked a student from Fontys to help prove that digital twins are useful and not too hard to make. Omron loaned her a small conveyor system with a PLC and sensors that are familiar within the industry. Cadmes gave her access to the software portfolio with all the great tools for virtual commissioning and building a digital twin. But how to connect it all together? First, virtual commissioning was set up. The 3D model of the conveyor belt was uploaded to Demystification and the behaviour of the belt and sensors was modelled. This was connected to Control Build with an FMU, which would allow co-simulation between the two through the Control Build shared memory. Then, Sysmax Studio was also connected to the Control Build shared memory to act as a virtual PLC and control the simulated hardware. Next, ways to connect the hardware and software for a digital twin were investigated. The first method the student established was using a Mosquito MQTT broker. This open source broker was used to connect the PLC IOs to the Control Build shared memory. This, when running with the co-simulation, made the digital twin. Once set up and connected, the needed I/O communications are bidirectional and automatic. This was nice, but to better tailor this to different SMEs, different methods should be investigated. The student kept looking. She then tried with OPC UA, a prevalent standard for modern PLCs. Like the other two systems, it used the Demystification Control Build co-simulation. This was connected to the OPC UA server on the PLC through the Control Build shared memory. Through this connection, the digital twin was made once again. Communication was still bidirectional and automatic. Another bonus of using OPC UA was shown. When using the virtual commissioning method already found, the PLC program can be directly uploaded to the hardware and used without the need to make modifications. The demo would detect the length and height of the object and show this in the digital twin. All the while, the position was shown accurately to the real world. Finally, objects contaminated with metal would be detected and stopped before the end of the line. They had done it. Not only did they have easy processes, but it also did not require any customized hardware or software, and only needed PLC programming and simple simulation setup. This meant that they could prove to SMEs that they wouldn't need to make costly investments to change their working methods and existing hardware to start feeling the benefits of digital twins and virtual commissioning. The student had also been very careful to document each step of the way and write up various how-to guides which could be shared with the SMEs. Helpfully, this demonstrator was small and easily portable, so it could be taken directly to the SMEs to see in person. Just be careful of the wires. Michiel from Omron said, "This demo offers a unique and highly effective way to showcase the added value of digitalization for machine builders and OEMs. By demonstrating the digital twin directly on site at the customer's location, we can bring both the physical and virtual twins together at the same table. This approach creates a tangible link between digitalization and real-world machine applications, something truly impactful and unprecedented." The end.